Okay, Calculus, Grade 12, Exam Questions, Cubic Function, May, June 2021, Grade 12, Exam, Paper 1, Question 9 from DBE. Okay, this is the question, Question 9. The graph of f of x is equal to 2x cubed plus 3x squared minus 12x is sketched below. A and B are the turning points of f. C with this coordinate is a point on the graph of f. Okay, this is the graph, a cubic function. 9.1, determine the coordinate of A and B. This question is 5 marks. Okay, let's get started with 9.1. A and B are the turning points of this cubic function, and at the turning point, the first derivative is equal to 0. Even in the case of a parabola, the first derivative is equal to 0 at the turning point. Okay, so we can use the first derivative to find the x coordinate of the turning point. Okay, we can use the first derivative to find the x coordinate of the turning point. Okay, and remember, at the turning point, the first derivative is equal to 0, even in the case of a parabola. Okay, so let's get the first derivative first. You have f of x is equal to this. Now the first derivative is equal to, you take the exponent times the coefficient. Okay, 3 times 2 is 6. X to the power of 3, you subtract 1 from the exponent. Okay, you have 3 minus 1, which is 2. Okay, you carry on. You have this exponent times this coefficient. Okay, 2 times 3, which is 6. Okay, so plus 6 times x to the power of 2 minus 1. Okay, you subtract 1 from the exponent. You're going to have x to the power of 2 minus 1, which is x to the power of 1. Okay, so you have 6x. And then minus, you have the exponent is 1. Okay, there is an invisible 1 there. 1 times the coefficient, which is negative 12. You are going to have negative 12. And then x to the power of, you have the exponent is 1. So you have x to the power of 1 minus 1. Okay, so this is going to be x to the power of 0. Okay, because 1 minus 1 is 0. And then x to the power of 0 is 1 times this. You are going to end up with negative 12. So to get the x coordinate of the turning point, you are going to let the first derivative equal to 0. Okay, you let it equal to 0 because at the turning point, the first derivative is equal to 0. So you are going to let the first derivative equal to 0 so that you can find the x coordinate of the turning point. Okay, let's do that. You let it equal to 0 because you know that the first derivative is equal to 0 at the turning point. So you let it equal to 0 so that you can find the x coordinate of the turning point. Okay, you need to divide by 6 throughout. Okay, you divide by 6, you get x squared, plus you divide by 6, you get x. You divide by 6, you get negative 2. This is equal to, you divide by 6, you get 0. Okay, you carry on. You are going to factorize this like this. Okay, you have x squared. You are going to have x times x, and you have 2. You are going to have 1 times 2, and you have plus 1x. Okay, so you need negative there and plus there. You carry on. This is going to give you x is equal to 1, right? Or x is equal to negative 2. Okay, so you have the x coordinate of the turning point. Okay, for A and B. So you can see for B is equal to 1 because B is on the positive side, and for A, the x coordinate is equal to negative 2 because A is on the negative side. Okay, so now you need the y coordinate when x is equal to 1 and when x is equal to negative 2. Let's get the y coordinate. You're going to take f of 1 to get the y coordinate of this value, and you take f of negative 2 to get the y coordinate of this value. Okay, let's start with f of 1. So you plug 1 wherever you have x. Okay, so y is equal to plug 1 wherever you have x to get the y coordinate. Okay, you plug 1 inside the original equation so that you can have the y coordinate. Let's do that. I'm going to use my emulator. So you plug 1 inside there. You have 2 times x cubed. X is 1 cubed. Okay, and then plus 3x squared. X is 1 squared, and then minus 12x. X is 1. This is equal to negative 7. Okay, so when x is equal to 1, y is equal to negative 7. Let's get the y coordinate when x is equal to negative 2. Okay, now you are going to take f of negative 2. You are going to plug negative 2 wherever you have x. Okay, let's do that. So you have 2 times x cubed. X is negative 2 cubed. Okay, plus 3x squared. X is negative 2 squared minus 12x. X is negative 2. Y is equal to 20. When x is equal to negative 2, y is equal to 20. Okay, so now you can see. So you can write it like this, negative 2 and 20. And b is on the positive side. Okay, so the coordinate of b are going to be this and this. Because b is on the positive side, the x coordinate is positive. Okay, like this, 1 and negative 7. Okay, let's carry on. We are done with question 9.1. Now it's question 9.2. 9.2, for which values of x will f be concave up? 3 marks. Okay, to find where the graph is concave up or concave down, you need to use the second derivative. Okay, you have the first derivative, you need the second derivative to find where the graph is concave up or where the graph is concave down. Okay, so you have the first derivative, right? Now you need the second derivative so that you can find where the graph is concave up or where the graph is concave down. Let's find the second derivative. Okay, you have that exponent times this coefficient. Okay, 2 times 6, it's 12. X to the power of 2 minus 1. Okay, you subtract 1 from the exponent. So you are going to have x to the power of 1. So you have 12x. Let's carry on. Plus, you have the exponent is 1. 1 times the coefficient is 6. Okay, 1 times 6, it's 6. And then x to the power of 1 minus 1. Okay, so you subtract 1 from the exponent, which is x to the power of 1 minus 1. This is x to the power of 0. And this gives you 1 because everything to the power of 0 is 1. So you have 1 times 6, which is 6. And this is a constant. You know, when you take the derivative of a constant, it's 0. Okay, now you have the second derivative. The second derivative is used to find the concavity of a graph. Okay, so we are going to say 12x plus 6 greater than 0 because you want to find where the graph is concave up. So you are going to say greater than 0. If you are interested to find where the graph is concave down, you are going to say less than 0. But you are interested to find where the graph is concave up. This is why you have greater than 0. Okay, so let's do that. You have 12x greater than, you take 6 to the right, it becomes negative 6. And then you need to solve for x. You are going to divide by 12 throughout. Okay, this gives you x. 12 divided by 12 is 1 times x, it's x greater than negative a half. Okay, divide 6 by 6, it's 1 divide 12 by 6, it's 2. So you are going to have negative a half. Okay, so the graph is concave up where x is greater than negative a half. Or you can write alternatively like this: x element of from negative a half to infinity. Okay, now it's question 9.3. Determine the equation of the tangent to f at point C. These are the coordinates of point C. Okay, the question is 3 marks. This is what you have to remember. The gradient of the tangent to this curve is equal to the first derivative. Okay, so the gradient of the tangent is equal to the first derivative. You have the first derivative. You have it. Okay. Now to find the gradient at point 2, because x is equal to 2, right? X is equal to 2. To find the gradient of the tangent at point 2, you're going to plug 2 wherever you have x. Okay. So this is what we are going to have. Plug 2 wherever you see x. Like this: 6 times x squared plus 6x. X is 2 minus 12. Okay, this is equal to, you can see this is 12 minus 12, it's 0. You have 6 times 4. 6 times 4, it's 24. Now you have the equation of the tangent is y is equal to mx plus c. This is a linear function, a straight line. You know that a tangent is a straight line, so it is in this form. Okay, so y is equal to 24x plus c. You need to get c. You are going to use this point. So this is x and this is y. The first coordinate is always x and the second coordinate is always y. Okay, so y is 4. This is equal to 24. X is 2 plus c, and c is equal to, you have 4. You take this to the left. So 4 minus 48. This is 48. 4 minus 48. When you take this to the left, 4 minus 48, this is equal to minus 44. Okay, so you have C. And finally, the equation of the tangent to f at C is this: y is equal to 24x minus 44. Okay, so we are done with question 9 from May, June 2021. Okay, I'm going to post more videos. Until next time, I will talk to you soon.